All right, guys, next. Once done, let's look at making azo compound. Guys, for azo compound, we have done it during pheno chapter already. So let's redo it. So the first step in the reaction between phenylamine, right? Okay, and nitrous acid highlight. Okay, is the reaction between phenylamine and nitrous acid to give a diazonium salt. We call this reaction as a diazotization. All right, highlight this first step. Okay, you can make nitrous acid using sodium nitrate. So guys, I take NaNO2 and a HCl. It's gonna turn into NaCl and HNO2. That is your nitrous acid. Okay, so guys, we need nitrous acid as start, yeah. Right, guys, next. The second step in the synthesis, right, okay, of the dye is the production of a benzene diazonium salt. All right, guys, I take a phenylamine. I add HNO2 and HCl, guys. Remember, you need two acid, nitrous acid and HCl. And this must be below 10 degree. Remember, yeah, must be below 10 degree. Okay, usually you do it around 5 degree. And eventually, right, this will turn into a diazonium salt. So how you draw a diazonium? Remove the H2. It's going to turn into an N, triple bond N, with a plus and a Cl minus. Okay, so this we call it as a benzene diazonium chloride, and H2O is formed. Since you have two oxygen, forms two H2O. So that is your benzene diazonium chloride. Done. All right, guys, again, the temperature must be kept below. Well done. Remember, it must be kept below 10 degrees Celsius because the benzene, highlight the word benzene diazonium salt, is very unstable. Okay, so let's say if you carry it out above 10 degree, right? So it turns into a nitrogen gas and phenol. Full page 10, can. I can't see top. Can you see it now? All right, guys, next. Let's look at page 11. All right, guys, in the third step, okay, a diazonium ion, right, will react with an alkaline solution of phenol. Okay, so react with alkaline solution of phenol in a coupling reaction there. Alright, so guys, if I take a phenol, Done. Okay, so guys, you get a phenoxide salt here, yeah. So it's a sodium phenoxide salt. Next, the diazonium ion reacts with phenoxide ion to form a yellow-orange precipitate. All right, guys, right now let's look at the diazonium ion. This is our diazonium, right? So I'm going to rotate it, throw it this way. No, sorry, I'm going to steal from here.
I think you have the same hat. I always see the same design.
Okay, what about bread? You want me to
Why? Oh, I have like 20 plus mark here. You guys always chose a random. Oh my god. Oh my god, you guys are really Alright guys, we have a N triple bond N here. Correct. And I'm gonna take a phenoxide ion. Okay, so I get a diazonium ion reacts with a phenoxide ion, so they form a coupling reaction. So guys, coupling reaction, right? This is an electrophile, yeah. So this electrophile, right, will attack the benzene ring. One more time, electrophile attack the benzene ring, and the hydrogen will go in front. So eventually, you are getting this compound now. Done. Okay, so you get this compound known as azo compound. And you have a nitrogen link bridge here, yeah. So I want you guys to highlight this nitrogen link bridge. This bridge is very, very strong. All right, next, the product is known as an azo compound, right? Okay, in which two benzene rings are linked together by a nitrogen bridge. So guys, if you see a N triple bond N, this we call it as a diazonium ion. Okay, which acts as an electrophile. Okay, then this substitute into the benzene ring of phenol at the fourth position, right? And okay, so this substitute into the benzene ring, guys, again, how it substitute? Okay, look at this, 1, 2, 3, 4. Do you see that your N triple bond N substitute into the fourth position? So originally there was a hydrogen here, right? All right. So all this hydrogen moved to the front. Can see that? Okay. So guys, let's look at this nitrogen link bridge. Guys, this nitrogen link bridge, right, is very, very stable. Why? Because, right, okay, the electron is continuously, okay, moving around, okay, between the two benzene rings via the nitrogen bridge. Again, guys, the electrons in two ring is continuously moving around, okay, via the nitrogen link bridge. Can see, so the electron is always moving around like that, which means the nitrogen link bridge is very strong, yeah. Okay, highlight, write it down, the delocalization, okay, of a pi ring system Highlight the delocalization of a pi ring system between the two benzene ring. Highlight through the nitrogen group. Makes your azo compound very stable. Yes. 9 to 10. Yeah, no, not today, man. Oh, confirm more is confirm more. All right, guys, next. So again, azo compound is often used as an orange dye. So guys, the reactant wise, right, I can take a phenylamine plus a HNO2. Bye-bye. Or I can take a NaNO2, react with a HCl. Okay, that's the first part. And also I need to take a phenol who react with NaOH to get a phenoxide ion. So guys, condition must be below 10 degrees. Usually we carry out around 5 degrees. So guys, at first, right, I take a phenylamine. I add a HNO2 to form a diazonium salt first. And this diazonium salt react with a phenoxide ion to form a azo compound. Reaction, coupling reaction. Why got bracket 5? Oh, I mean, usually in exam, we just write as 5 degrees. Below 10 degrees, but usually mark scheme, you will see 5 degrees, 5 degrees, or sometimes below 10 degrees. Hey guys, once done, next page.
What's the house? I thought it's talking about dying.
Too fast, wait, go back. Too fast, man. Really? Okay, I'll let you guys copy first. Done. Sure, halogenoalkane and CN is SN1 or SN2? Right now, guys, let's look at amide. All right, kid, this is how an amide look like. I want you guys to draw amide first. C double bond O and an NH. Okay, so CONH, that we call it as an amide group. Okay. So amide is derived from a carboxylic acid. Instead of a C double bond O OH, you turn it into NH2 here. Okay, so amide group is represented by the formula CnH2n plus 1 CONH2. Okay, that is the functional group. Sorry, that is the formula for amide. Guys, is amide acidic, alkaline, or neutral? Thank you very much. It's neutral. Bro, what are you singing? You tembak correct? Mana boleh tembak? Cannot be ah. Yeah, Minh Yun got A, you know. Jangan main lah. Yeah. Okay, so remember they are neutral. Why? Because the lone pair on your nitrogen is being sucked by your oxygen, right? So your H plus cannot go into the N, right? So it's neutral, yeah. Due to the presence of the highly electro-withdrawing or electronegative oxygen atom, right? Okay, highly electronegative oxygen atom presence in the amide group. Hence, the lone pair on your amide nitrogen atom not able to receive H, right? Alright, guys, now I want you guys to look at your amide. I want you guys to name it, yeah? Go. Alright, guys, 3 amide given. Please name it now.
This without search.
Does methyl amide exist? Yes, methyl amide exists. You're right. Methane amide exists. Guys, first one we call it as an how many carbon? 2, which is 2 carbon is a E 10 E 10 E 10. Am I right? Second one. Okay, 3, which is a propane amide. Guys, remember your amide as just like a carboxylic acid, they always take position 1. So this is a 2-methyl propane amide, right? Or methyl propane amide. Alright, guys, next one. Alright, guys, 1, 2, 3, 4. What do you call it? This butane. Am I right? No E, my bad. Alright, guys, for butane amide. 1, sorry, 1, 2, 3, not 4. Again, this is a carbon, this is not a carbon, yeah. So 3 chloro butane amide. Done. Okay, guys. Okay, so if you look at the amide, we have 1, 2, 3, 4, right? Okay, so 4 amide, we call it as a butane amide. Okay, and guys, whoa, we have a methyl group, right? And the methyl is in the position, is in the third position, right? So we call it as 3-methyl butane amide. Alright, guys, next. You see, right? The letter N, whenever you see a letter N, right? Okay, letter N is used when your hydrogen on your amide is being substituted. Alright, guys, example. Okay, let's look at the N substituted amide. So I have a butan ethane amide. Okay, so guys, you can draw a butan first. 1, 2, 3, 4 amide. Correct. So guys, again, you see 1, 2, 3, 4. That's your butan amide, right? And guys, and ethyl, which means one of the hydrogen is being substituted by ethyl. 1 carbon, 2 carbon. That's it. Understand? Hey guys, next, draw now. Chapter 30, baby. 30. Hey, I realize some of you guys been skipping my Thursday class. Don't skip, yeah. Because we are almost done with ionic equilibrium already. Yeah, and we are done with transition element. If you skip means GG, yeah. I'm not gonna redo the chapter, yeah. Thank you, baby. Hey guys, now let's draw. How? Methan ethane amide. So draw a methan ethane amide.
Johnny, why your hands so messy?
Oh, I tell you. Okay, I don't intend to. Guess what talking to?
Alright, guys, you see, right? Your methan ethane amide is here. Connected to a propyl. Why you are so late? I'm not found you a girl that you might like. Alright, guys, next. Methyl ethane amide. So ethane amide is 2 carbon, right? 1, 2. Okay, and you have a methyl, right? Done.
Do you see the?
That's how much you earn.
What brand? Laneige. Laneige. No, not very expensive. 80.
70.
It's very close.
It's not very expensive.
It's not very
Is it
expensive.
very-
Very expensive. Yeah, very expensive. Oh, of course, bro. You haven't started working yet. You guys are making $0 a month.
Why you bring bananas?
Cannot is it? I steal my brother hoodie because my outfit today very exposed.
Who is your brother?
Don't want to you. Well, rape my brother. There. Johnny, come. I drop. Hi guys, next. Okay, let's say right, if you have 2 hydrogen being if you have 2 hydrogen being substituted, right, guys? Let's look at it. There's no more hydrogen left, right? Okay, so we call it as an NN, double N. Yeah. So we call it as NN di. This is an ethyl, right? 4 carbon butanamide. All right, guys, let's draw now. All right, guys, let's go. And methyl methylamide. So, guys, let's draw a methylamide first. C double one O and right. All right, guys, I can draw a methyl first. I can also draw ethyl. Done. Law. Understand? All right, guys, next. And dibutyl butanamide. So let's draw butanamide. 4 carbon. 1, 2, 3, 4. Dibutyl. 1, 2, 3, 4. 1, 2, 3, 4. Done. Next page. Guys, I'll get this chapter done by today. What you guys are doing now in school? Oh, yeah. I think equilibrium. Finish KSP. Okay, good. Next week we are doing KSP. Good. We will finish the syllabus relatively early. By end of February, we'll be done. So we have 2 months to prepare. All right, guys, next, let's look at the physical property. All right, guys, for melting point, right, most of the amide are solid. Okay, so guys, the melting point of amide are high because they can form hydrogen bonding. So again, you can highlight your hydrogen bonding. You see that? Okay, next, if you look at amide are soluble in water, yeah. Just taking A2 in October, November, right? All right, guys, next. Okay, reaction of amide. So guys, for amide, right? Okay, ethanamide can be made by reaction of ethanol chloride with ammonia under room temperature. All right, guys, let's say, right, if I have this ethanol propanol, no, you want ethanol, right? So I withdraw my ethanol first. Sorry, my bad. Ethanol chloride. Add NH3. What do you get? Ethanamide. Let's see. And guys, can anyone tell me what is the mechanism for this reaction? whenever you have an acyl chloride, thanks. It's always Hao Jie, right? It's Hao Jie. Thank you. Addition, elimination. Thank you, Hao Jie. Good job. Yeah. So guys, remember, yeah, any reaction with acyl chloride is always addition, elimination. Okay, next. A primary amine such as ethyl amine, okay, can react with an acyl chloride to form a substituted amide. So guys, this time, okay, I have this amide right now. Sorry, this acyl chloride. We call it as a propanol chloride. And kid, I'm gonna react it with an ethyl amine. Go. All right, guys, join them. Get me the amide and name the amide for me now. Well, attendance. Your friend look very depressing at you. What happened to you? All right, guys, what's your answer? One, two, three, double one O, and it's bonded to NH, right? Is that correct? Okay, so guys, this we call it as an ethyl and a propane amide, right? Well done. And don't forget a HCl is formed here. So this reaction, right, can happen at room temperature because acyl chloride is very reactive. And you will get a white fume of HCl. Yes, boy. Can. All right, guys, next. Okay, let's say, right, kid, if you have excess amine, how? So, guys, again, if you have a lot of amine, right, so this amine can substitute here again, you know. Okay, so it will make a salt, it will react with, okay, your HCl form to make a salt. Yeah, I should have another. Okay, guys, I put it here because there's another reaction. Guys, let's say, right, if you have a lot of amine, so this amine can substitute away your H again. Nah, it's fine, it's fine. Don't need, it's okay. Just leave it. Later, I'll give you one example. This is, yeah, don't care. So, guys, if I have a lot of amine, this amine will react with the HCl form to form a salt, which is a NH3Cl. Done. All right, guys, now let's look at the reactant. So the reactant, right, what do we need? We need an acyl chloride added with either an ammonia or an amine. Condition and reagent. Again, guys, acyl chloride is very reactive. So room temperature will do. Yeah. It can make NN in excess. But later I will show you how, Jay. You are right. Yeah, later, but not for this one. Because this reactor will not. But later I'll give you another reactor that will. Okay, so guys, acyl chloride. We'll add it. You can get an amide or an amide, yeah. Addition, elimination. Done. Alright, guys, next, hydrolysis of amide. So, guys, what is hydrolysis of amide, right? It's just a breaking down of amide, yeah. So, the link, right, can be broken down by either an acid or alkaline hydrolysis. The short form. What do you mean by the short form? Which one? What short form? Yeah, why? The short form NH3Cl, that one, yeah, why? Got name, no? Alright, guys, now, let's say, right, if you are given this amide, R1, C double bond O, connected to NH R2. So guys, when hydrolysis occur, right, you are breaking down the amide linkage. So the amide linkage is broken down. Okay, and let's look at this N-amide. Okay, so guys, when you break this here using acid hydrolysis, right? Example, if I add a HCl, okay, so this entire thingy will turn into a carboxylic acid. This entire thingy will turn into an amine. So basically, this part turns into a carboxylic acid now. Can see that? And this turns into an amine. Okay, so let's say, right, if you have excess acid, then this will turn into a NH3 plus. Done. A salt. All right, guys, let's say, right, if you put it under alkaline hydrolysis, which means, yeah, you are putting it with a base, example, NaOH. Okay, so you are not getting an acid now, you are getting a salt. And you will get an amine. So example, right, I use NaOH here. So it's gonna be COONA and an amine. Done. So this is a carboxylate salt. Alright, guys, next. So, guys, I can say that, right? The product of a hydrolysis of an amide with an acid, right, is a carboxylic acid. And an amine, right? Then what happened to the amine form? Amine form will react with excess acid, make ammonium salt. Done. Okay, page 16. Okay, let's say, guys, if you have an unsubstituted amide, okay, if I have an unsubstituted amide, okay, with acid, so the product is just a carboxylic acid and ammonia. Okay, next, the ammonia in solution reacts with excess acid to make ammonium salt. So, guys, again, if I take this and undergo a hydrolysis, alright, guys, what's your answer? So if I break it here, right, what will be? This entire thing will turn into a carboxylic acid, right? And NH3 is formed. Done. Okay, so again, guys, if it's an unsubstituted amide, you are getting carboxylic acid and NH3. So the product are carboxylic salt and an amine. But guys, if you reflux an unsubstituted amide, okay, you are getting a carboxylate ion. Alright, guys, this part, give me a second. I need to go washroom. I paste over the answer over. Paste over the answer. Give me a minute. I want you guys to. Yeah, refill. All right, guys, go. We're out now. The second I'm working. Hey guys, next page, go. Okay, amide. The last reaction of amide already. Chill. Don't scroll away too quickly. I can't see the carboxylate ion and carboxylate ion and what? Which one? Carboxylate ion and NH3. Done. Okay, guys, page 17. Let's go. Alright, guys, again, what is reduction? So reduction reaction, right, is defined as adding hydrogen, removing oxygen, right? So again, amide can be reduced by using LiAlH4, yeah. Alright, guys. Oh my God. Okay, so guys, reduction is adding hydrogen, removing O, right? So I just have to add 1, 2 here, right? So eventually, the double bond is no more, gone. And you get a H2O. Done. Okay, so in total, right, you're adding 1, 2, 3, 4, right? So 4H here. So guys, for the reactant, I have amide added with LiAlH4. Amide is converted into amine. And guys, the mechanism reduction, yeah. Done. My iPad died. Lord. Wait, give me a second. Let me charge it. Oops. Brass up. No, no. A second, yeah, guys. Restarting my iPad. Alright, guys. Oh my God, bro. I've written something. When Conley. Wow, my lazy copy. Done. Okay, right now let's move on to the last part, amino acid. Wait up. Okay, right now, guys, let's look at amino acid. Kid. Okay, so for amino acid, right, this is how we draw it. So amino acid are compounded, okay, compounded, a compound that contains a COOH group and an NH2 group. Okay, so the general formula for carboxylic acid, for amino acid, right, guys? So amino acid, you can always imagine it as a, okay, as someone. So guys, you see, right, it's basically the same as a human. So you see, right, you and I, what differentiates between you and me, right, is just the phase. So the same thing for amino acid. It's the phase that is different. Carbon in the middle, the phase is an R group. I do not know what, okay, I do not know what type of R group you will have. Okay, you have different type of R group, which gives the name of your amino acid. And one side, one of your hand, it's a C double bond O OH. Another hand, NH2. And finally, you have a leg, hydrogen. Okay. So guys, what differentiates between all the amino acid is always the phase. It's the phase that is different. Wednesday, 7. 7 to 8:30. KD.
No, you guys lah.
Go keep guys.
Just not me see the women.
And you really got a lot of QS. You must come. Damn, you missed it one.
I'm gonna come and
Okay, guys, next. So the R group is the part of amino acid that can vary in different amino acid. Yeah. So the simplest amino acid that we have is a glycine. So guys, if you were to look at your data booklet, you can open up your data booklet. So data booklet, right, has the name of the R group. You see, right? Look for glycine. It's here, right? So glycine, the R group is a H. Can see that? So you just have to replace the H with a H and done. Okay, that is a glycine. All right, guys, next, alanine. You see alanine, the head is a CH3, right? Okay, so guys, the R group, right, can either be acidic or alkaline or neutral. Done? Next page. All right, guys, 18. Hey, what is this? Yeah. Oh, okay. Okay, let's go right here. If I take an amino acid,
Would you like to join us, or would you like to go
Okay.
to dinner with boyfriend?
give me a second, let me think about it. Okay, Namana, I give you the in terms of I'm not invited. Okay, so guys, you see, right? Let's say if you have this amino acid and I dissolve it in aqueous. Alright, so guys, when you dissolve an amino acid in aqueous, right, what do you get? You get a Schweitzer ion. So one side you get an RCO minus, another side you are getting an NH3 plus. Done. Okay, done. Alright, guys, next. What do you call this ion as? Again, this type of ion, right? I want you guys to put it down. Okay, this we call it as a Schweitzer ion. And guys, what is a Schweitzer ion, right? In Schweitzer ion, the net charge is always 0. Done. Okay, next. So this ion is known as a Schweitzer ion. Okay, as it carry 2 charge. So NH3 is a plus, right? COO minus is a minus. Okay, hence the net charge is 0. Okay, next. The ionic property of this Schweitzer ion, right? Okay, give your amino acid, highlight the word ionic nature of a Schweitzer ion. Give your ionic compound, sorry, give your amino acid relatively higher melting and boiling point? Why is this room so hot? A bit shy. I'm a bit shy. Alright, guys, next. If alkaline is added, sorry, a solution of amino acid, right? Highlight the word solution of amino acid that contains a Zweiter ion is known as an amphoteric solution. Guys, what do you mean by amphoteric? Buffer, correct. Okay, so it's a buffer. It can react with both acid and base, right? So highlight the word if acid is added. Then the CO minus part of the Zweiter ion, right, will donate the H plus. Sorry, will receive a H plus to form COH. So guys, let's say, right, if I have a Zweiter ion, okay, and if you add an acid over, which is adding a H plus here, what do you get? So it will combine with your COO minus, right? Boom. And turns into a COOH. All right, guys, next. Okay, when alkaline is added, how? So NH3 part of the Zweiter ion, right? Okay, so we'll donate a H plus. So guys, again, you see, let's say if I take this Zweiter ion and I add a OH minus here. So what this Zweiter ion gonna do, right? The H plus here, they're gonna donate out. So you will get this thing.
You chọc chin. Chọc chin lah.
Okay, NH2 and a H2O. Alright, guys, done. If done, next page. Done. Okay, next page. Okay, peptide plus H2O. Sorry, the H plus one of the hydrogen goes to the OH. Okay. Yeah, peptide, and we're done. Yes, the last one already. Not yet we have. No, we still have electrophoresis. Not that early.
How long lah? MBTI.
Alright, guys, now let's look at peptide. Okay, for peptide, right, the acidic COH and amino, okay, will react with NH2 group. So again, if you take two amino acid joined together, you will get a peptide. Yeah. Alright, guys, come. I want you guys to choose two amino acid for me. Go, pick two. Pick two amino acid, any. Go. Pick one. Glycine. And I put a glycine and a alanine. Ala. Okay, glyla. Glyala. Alright, guys, let's draw a glyala. Yeah. Okay, so glycine plus alanine. Okay, so guys, how to draw a glycine? God. Right. CNY. Okay, so guys, we're gonna draw a glycine added with ALA. So glycine added with ALA. Okay. And now guys, please combine them. So you see, right, when you're combining them, OH and the H will be gone. Change it to other color. Who else? My student lah, walao. Hey, wait. Glycine is a H, right? Why am I putting a G here? Oh my god, sorry. Alright, guys, the resulting molecule, we call it as a glyala. Okay, a glycine and an alanine. Do you see a peptide linkage here?
Not that.
Yep, I'm done. Done? Okay, so guys, the reaction, right, it's a condensation reaction, yeah, guys. So we call this as a condensation reaction. Why? Okay, as a small molecule is eliminated, right? Okay, so a H2O molecule is eliminated, correct? Okay, so the dipeptide, you still have a NH2 and an OH. So you can still bond something here and you can still bond something here. So this reaction can be ongoing. Okay, so you can bond another part to form a tripeptide. And if you make it longer, it's going to be a polypeptide. Yeah? All right, guys, done. Skip. Now, kid, all this question, I'm not doing it. I want you guys to flip to page 36. Electrophoresis. Ciao, electrophoresis. Yes, correct. 36. All right, guys, now let's look at electrophoresis here. All right, guys, for electrophoresis, right, it's used in the biochemical analysis. Okay, and the purpose, right, is either to separate or also to identify amino acid, yeah, remember, yeah? All right, guys, we can use it with amino acid and peptide obtained when a protein is hydrolyzed. Yeah? Okay, so again, so positively charged ion, right, will always move to the negative plate. And the negatively charged ion will move to the positive plate. That's it. Oh. All right, guys, next. The sample, right, is placed on an absorbent paper, yeah. Okay, or a gel supported on a solid base. Okay, and you have a buffer solution. And guys, highlight this. Larger ion will move more slowly. Okay, so higher charge. Highlight another one. Highly charged ion will move quicker. More quicker, oh my God, more quickly. Okay, next. Therefore, the ions are separated as the electric field applied, and you get a series of lines, okay, on the paper or gel once the chemical is applied. Yeah. Okay, guys, you see, this is how a gel electrophoresis work. Yeah. So you get an absorbent paper. That's like damn weird. Oh my God. All right, guys. Okay, at first, right, this is where we place our sample. Okay, and you have a positive terminal. You have a negative terminal here. Okay, so when you apply it, right? Okay, so you get a series of bands or series of dots. So you get to see like some sample here. So these are all the different separated amino acid. Yeah. Done.
Chứ lại phải chạy con
Ding, ding, ding.
phải chạy
I think that
khi mà bài chạy con đến sáng nào đang sạc đèn đang sạc đèn
done. Okay, guys, once done, next page, please. All right, guys, now let's look at one example. Yeah. Okay, you see, okay, this is where my starting point is. And after running your electrophoresis, okay, so I get a series of spot A, B, C, D. All right, guys, now what we can deduce from the spot A, B, C, D. Again, let's look at spot D. Guys, I want us to circle spot D. And guys, look at spot D. Is it positive charge or negative charge? So spot D, right, must be positively charged, correct? Because it's moving towards the negative plate. Am I right? Yes. All right, guys, next. What about spot C? Do you see that spot C is not moving at all? Which means spot C is neutral, right? Or no charge, right? Correct. Okay, guys, what you can deduce about A and B? They are what charge? Okay, so spot A and B are positive or negative charge? Negatively charged, right? Am I right? Alright, guys, but which one move faster? A move faster or B move faster? This is your starting point. A move faster than B, right? So I can mention that A move faster than B. Correct. So which means A is either lighter than B, correct? Or having a higher charge than the B, right? Am I right?
I think
I want. Okay. Okay, guys, now let's look at spot C. Again, right, for spot C, you see that spot C has no net charge. Can see that this entire amino acid has zero net charge. Okay, so guys, let's look at C. Okay, when you ionize it, right, they form a Schweigert ion. So look at this compound. When you put it under aqueous, right, they turn into a Schweigert ion.
Oh, I feel like that is useful.
Okay, so do you see that your C, right, has no net charge because you have a negative and a positive charge. So which means, okay, this compound will not move because it's electrostatically neutral. Sure, can take a short break. I want to get water. Can go. 2 minutes. 1 minute. Go.
What? Wait. I don't know. It's like.
see my hand.
Oh, my student, you see what they are doing? Oh my god.
Yeah, I'll try to remember the. What are you doing?
Nothing.
Don't record me.
No recording.
Please.
Go continue.
Recording.
No.
So then what?
Go continue.
Yeah, I'm learning. I'm learning.
Continue your dance move.
I'm learning.
We are learning chemistry. This fellow doing what? Rave move. Ayo. GG lah, you guys. What the
What is
hell?
the easiest thing?
Insane. Insane. Okay, guys, next. Spot D. Gone. Gone. Alright, let's look at spot D, guys. You see, right, for spot D, it moves towards a negatively charged, right? So which means it must be a positive charge. Huh? So the amino acid move towards the negative plate. Okay, due to the net positive charge.
How do you mind? You can use me.
No. Yes, we are. Okay, now, so guys, in the buffer solution with a pH of 7, right? So again, yeah, so which means, right, you must have extra NH2 group, okay? You must have extra NH2 group. Reason being, right, your NH2 group would ionize into a NH3, right? So guys, it might look something like that. Or
What? Another one.
okay, so again, in order for you to have an extra NH2, right? So it must be this compound. So I know that it must be a lysine. Okay, it's because lysine has extra NH2, right? Okay, so I can draw a lysine out. How many CH2 again? 1, 2, 3, 4. Okay, good. All right. So guys, you see, right? So when they ionize, so it turn into a NH3 plus, COO minus, and a CH2 4 and NH3 plus. So guys, do you see a net positive charge here? Done. So you have a net positive charge, which means it's moving towards the negative plate, right? Done. Oh yeah, come here, do chemistry, go and do.
I was doing chemistry for 1 hour just now. Just now. So long.
You are really. Ten already. No, it's 2. You still have how many more pages? 38, 39, 40, 41, wow, 42. Yeah, I don't think I can finish. All right, guys, 37 done, 38. Let's go. All right, now, so again, for spot A and B, right? Do you see that your spot A and B travel to the positive plate? Okay, which means that they must be negatively charged. So guys, again, in order for it to be negatively charged, they must have extra COOH group. Okay, guys, again, they must be carrying an extra COOH group for it to be negatively charged. All right, guys, this is your amino acid. Go. Draw at pH 7 when they ionize.
This one better than my album now. Really? She's bad. No, she's very bad.
All right, guys, when they ionize, it turns into a R, COO minus, COO minus, H, and H3 plus, right? So guys, do you see that you have a net negative charge here? Okay, can. But guys, if you look at it, right, you see that spot A move faster than B. Okay, which means the R group, right, for spot A is definitely lighter than B, right? Okay, so I can mention that A move more than B. which means A R group in B is heavier than A, right? Understand? So which means the R group in your B, right, is heavier or greater or bigger compared to A. So which is why A moves faster because it's lighter, B moves slower because it's fatter. Done.
Have you been to English?
Sorry?
English.
Pinkfish. What's that? No.
Oh.
Has he? Alright, guys. With that said, I'll stop the session here today. I'll see you guys next Thursday. Yeah. Okay, next Thursday we are finishing up our ionic equilibria. Next week I'll get ionic equilibria done. Okay. And Friday I'll get this chapter done.